G'day. Today we're going to go exoplanet hunting on the iPad. You heard it. Global rentoscope, 20-inch plane wave CDK telescope in New Mexico, driven from this iPad. We are going to capture a 2-hour run on HAT P3b, the exoplanet, and see what we can find. It's a 14 millimagnitude transit, so it's very shallow, but I think the 20 inches up to it, and we're going to do it right here. So here we go. So here we go, we'll just log on to, so here you can see we can log straight into G11 because it's available, and here's a beautiful photo of the scope there. It's a plane wave 20-inch CDK with a new focal reducer, right? So it's only f4.4 now, and when you get onto the telescope, you can, as you can see over here, we can go to the left-hand bar, and we can say generate a plan and save that plan. We can make a reservation or look at pending reservations and observe the system status. So we've already got a plan in here, so we can go straight to the section that says run scripted plan, so we can just click on that and that will start our plan going. We can select our plan here. We're FSAUR is out of season now, so we're not working on that. We're going to have a look at HAT P3b tonight. So we can select the HAT P3b plan that I've already loaded and select send my images to the VFOT server. Now the VFOT server is where we can store photos that have been calibrated and plate solved so that they can go through a process of virtual photometry on a cloud-based service called VFOT. We can also check the all sky camera here and make sure it's nice and there's no clouds. You can see the Milky Way just coming up in the east there, which is quite good. And then we click on acquire images and away we go. And so that telescope will pull the plan off the telescope's computer, and we'll commence that and it will start running it, and we can look at that in the system status, and we can observe the process of that run. So if we go to system status, which is the virtual photometry tool that we use with the AAVSO, the VFOT tool is a cloud-based photometry service available through the AAVSO and linked with a partnership to Global Rentoscope. So we can just select all the images now of HAT P3b, and we can do a time series on that on the 100 images we took during the transit. So this will take a moment or two. You can see we'll select the sequence that we want to run. This sequence contains the standard comparison star values in the V Johnson filter range, and we can start the analysis straight away. And as you can see, we have the first image and last image in the journal day timing there, and it'll go through now and process each of those images. And as you can see, there is some variation there obviously, which is normal in photometry. And as we're about 19% complete now, the onset of the transit period was about the 25th to the 32nd image. So you can see now that the magnitude is starting to drop as the exoplanet passes in front of the parent star, and we're about 44% complete now. You see that the transit at the limb of the star is now complete, and we're getting down towards the depth of the light curve transit. So the transit for HAT P3b is predicted to be 0.014, which is 14 millimagnitude. So G11, this telescope, is quite sensitive It's got a focal reducer on it now, which gives it an f ratio of 4.4, and it can easily detect that sort of slight decrease in magnitude during the transit. So we're about halfway through. Now this is processing all 100 of the 30-second images. Each of these 30-second images are about 30 seconds to a minute apart. So there's about there's about over 2 hours of data here, 2 to 2.5 hours of data. So it's just through there. You can see how even at that level, you can see here that the star has definitely dipped, and now it's just coming. We'll only catch the first part of the egress, but certainly you've got the ingress and the floor of the transit there, and then you can just see the magnitude starting to creep up again as the egress commences towards the end of the session, which was about an hour before the dawn period commenced, which was quite fortunate on that particular day. So you can see here there was definitely a dip in the light curve. As you process that data and reduce it, we will get a better, tighter view of that data. So there you go, an exoplanet transit on the iPad, driving a remote telescope at New Mexico through global rentoscope.